Hello and welcome. Uh, we are starting a bit late. I'm so sorry about it. We are starting almost 13 minutes late. Welcome to my first class on thermodynamics. Are you guys able to hear me? Please write in the chat box. I have made oh, yes. What has happened? Hello. I think I'm yes. Ramesh Naik has written. Oh, I am Prabhu. Yes. So Prabhu, please write once again. Am I audible? Once again you write, so that I will be having all set to start. Am I audible, Siddharth? Rituparna, am I audible? One more. Ritu, am I audible? Yes, okay. We'll start. So, welcome once again. We are today late by maybe 15 minutes because I was struggling. In fact, it is very challenging for me that I am using a software called OBS, which is a streaming software. It's not a streaming gateway. Facebook is the real streaming gateway, but with the help of OBS, I will be changing over from scene to scene. Now I am talking with one scene where my whole video is being captured in one frame. Now I'll be using the other frame, other scene, where I will be using the PowerPoint slides as well as my OneNote writing. Now, thermodynamics is a very fascinating subject for me. Although it has a major leg in physics, minor leg in chemistry, but to me it is more fascinating as a physical chemistry topic, because the thermodynamics principle is applicable everywhere. May it be your primitive internal combustion engine, car engine, diesel engine, or now also nuclear power plants, refrigerator, air conditioner, heat pump. Now even in lithium ion battery, nowhere in this world, even nanotechnology, nowhere you will find there is no application of thermodynamics. Although in thermodynamics we have two things. One is ideal, the other one is non-ideal. Ideal, we have to study the rules and regulations, the principles we learn. That is our target. We have to reach 100% ideal. We cannot ever be. That doesn't mean that we will not try to come closer and closer to the 100% ideal value. So we set the ideal here with the thermodynamics principle, and because we are very fast people, and we know we have a saying in Odia, not in Odia, English, slow and steady wins the race. We are not slow. We do everything fast. Any fast process, remember, in the language of thermodynamics is called irreversible process. But I will tell you its implication, its meaning in chemical science. So here lies my experience will come in when the thermodynamics will be applicable to chemistry, not only to physics, from where it was originated. Let me concede to the physicists and of course to my physics colleagues that yes, it did originate from the arena of physics. Now, when people wanted to use it in chemical systems, chemical reactions, chemical changes, then they were not possible to explain unless we have to upgrade the principles of thermodynamics. And it did happen. Therefore, I will be telling every now and then, of course, we'll be setting. If we are talking about heat engines, then reversibility, irreversibility has some meaning, but we are talking of chemistry, chemical changes, reversibility, irreversibility have a completely different meaning. So that's where the experience of a teacher comes in to tell you thermodynamics is not merely a science of thermal energy, energy changes, work, thermal energy changes, but also is important to predict whether a particular system has a driving force to go ahead or cannot, or if it goes, where it will stop, very close to the target or in the midpoint or very close to the starting point. All these predictions, not only energy changes, there are, I'll tell you, I'm with this introduction, I'll be coming back to my other stream. I'm finding a lot of Biravar sir, namaskar, parents man jo mane achanti, semane just dekhi paranti what I am doing, but students who are watching may be first timers, like class 11 students, like some of you, Siddharth and Prabhu, and maybe revisioners who are appearing NEET, JEE, even second time or third time or first time, revisioners, they also will get benefits. So I will make a compromise between the beginners who do not have any idea about thermodynamics, also who have already studied once, if they are in class 12, for example, or 11, their school, they have been already taught. Fine. And the third category is who are revising. All of them will be benefiting from what I will be interacting with you for the coming 5 days for 2 hours each day. That will benefit you not only in solving problems, objective questions for your NEET and JEE, but also to capture the real concept. And I'm inclined to believe, I'm sorry if I'm wrong, my colleagues and others will correct me if I am wrong, that students often in this chapter memorize the equations and solve problems. They get their answers correct and they get mark, forget about it. But what is that fascinating science really tells us? Probably they miss out, probably. We do not have much time to share with our experience with them. Let's try. Now you can see this where I will be writing and also talking to you and also looking to your Birabar sir, you please tell your class 12 students to watch for the 5 days. That will definitely benefit. I'm sure he might have completed in class 11 thermodynamics, but let him sit with me for some time. If he feels monotonous, then he will just quit, leave, allowed. But if not, let him continue. Not only he will revise the topic, but also learn many new things. I can assure you that, Viravar sir. Okay, thermodynamics is not merely this science of energy, it is also the science of possibility and direction. So we will be doing something. I ask you to catch hold of a pen and a copy, a blank copy where we shall write. I will not be teaching from the PowerPoint slides I will share with my file all the PowerPoint files with all the secrets of my experience will be public to you, will be made public to you, but you write. Now, in thermodynamics, what we are interested to know that supposing we are studying a gaseous system. It started from here in physics, from gaseous system. Gas, and simply we are going to expand or compress. From this, thermodynamics began. So this is, there are two possibilities. One, the system can be open. This is a closed system because no matter can escape or no matter from outside can enter, because all are closed. But I'm talking of open. Supposing this movable cylinder is not there, it is open. It is a pot like a glass containing hot water or a cup of tea, open. That's an open system where matter can exchange. Matter, some water vapor will escape out and go out, or some fresh substance can come in. So the matter exchange is possible in open system. So we are not interested, but in chemistry we are. We will be doing chemical reactions in open under 1 atmosphere. In that case, also it is taking place under constant pressure condition, because over our head, over our container where we are carrying out chemical reaction is atmospheric pressure. So whatever is happening, the chemical process is happening. Even if it is not involving any gas, if there is a gas, we'll definitely put a cover, movable piston, to see if it is under constant pressure, 1 atmospheric pressure, whether the piston is moving up and down as things are going on inside. But if all are aqueous phase, solid phase, then we don't need to put any piston or any stopper. We'll leave it open and leave to the care of atmosphere. Now this is one open system, and what I have done, this is a closed system where matter cannot but energy exchange is possible between, this is the surrounding, all these things are surrounding, and this is our system. We are studying a gaseous system will expanding and compressing, or a chemical reaction inside a closed vessel. And the last one is isolated, where this will be having an adiabatic boundary. Insulation. If you make an insulation, everything insulated, then ideally no heat can enter, no thermal energy can enter, or no heat can enter or escape. No heat. I tell you, heat. Remember, heat is not really an energy. We always commit a mistake in saying heat energy. No, heat is a mode of energy transfer, like work. We will talk about that. Work and heat. They are two different currencies, like dollar that we are spending now here. Oh, by the way, I am Sudhanshu Tripathi. I am the head of an institution called the Uranium, which is now having its 25th year to popularize chemistry in school level, from class 9 to 12. 9 to 10, mostly focus on vernacular medium, Odia medium. And 11, 12, they have to understand English, speak English, whether they hail from Odisha or anywhere in the world or non-English speaking country. They have to acquaint themselves, familiarize themselves in understanding English and talking in English. Therefore, all my programs for class 11 and 12 are done in English language. But that doesn't mean that I will never ever talk Hindi. Though defectively, my Hindi is not very, very good. But yes, I do talk in Hindi. And of course, in our mother tongue, Odia. But when I feel that I am not able to communicate in English, then only I will come down to an Indian language starting from Hindi, Odia, or whatever. So, remember this. I will ask you questions. Are you watching, Ritu? Yes, sometimes you go on giving me Gitanjali. Oh, you are Mahesh. Mahesh, if you are watching, just keep on telling that yes, you are live. And I am also live. Live में जो मजा है, ये dead में नहीं. I'm just kidding. So there are three types of systems: that open system. Chemists were very familiar with open systems. Closed. In open system, everything can exchange. Matter, energy, everything can exchange. Closed system, only energy, no matter. Isolated, matter no, energy no. Because this is insulation. Adiabatic, that is called insulation, is called adiabatic boundary. In closed system, there is conducting boundary. It is called diathermic wall or boundary. Diathermic wall, this is adiabatic wall in isolated system. In isolated system, we will carry out any process that is called adiabatic process. Whatever, compression, expansion, whatever chemical reaction, stirring, anything that we will be doing in an insulated vessel, say a thermoflask, that process will be called adiabatic process. Remember this. And closed system has a conducting wall, although closed, but conducting wall. So here we can carry out isothermal process, isobaric process, so many other processes, all non-adiabatic processes. There are so many non-adiabatic processes that we'll be discussing. Those can be carried out in closed system or in open system. Most common is the closed system, because we will know that we guys are very fast, do everything fast, eat fast, walk fast. When we drive, we also fast. We don't wait for anybody. Give me some space, I will go. As if we have been loaded with so much of work. We have only work in the living present God within, heart within, God overhead. We have only work, nothing else, so we don't have time. कभी कभी सिद्धार्थ नमस्कार, कभी कभी हम बोलते हैं इंडियंस इतने जल्दी में क्यों होते हैं? हमेशा जल्दी में होते हैं. रास्ते में जब जाते हैं स्कूटर में या कार में, हमेशा जल्दी में होते हैं. जैसे कि कुछ काम है, कुछ काम नहीं है, लेकिन हमेशा हम जल्दी में होते हैं. रास्ते में हमको जगह छोड़ो, हम जाएंगे पहले, तुम पीछे आओ. तो हमेशा जल्दी में हम सब होते हैं. That is why even we are carrying out a process in a diathermic wall, I mean in an open or closed system having diathermic boundary or wall, we are doing sudden compression, sudden expansion, then that will be an instantaneous adiabatic process. Instantly there will be change in temperature, change in pressure, change in volume, everything will happen. Then gradual, equilibrium will appear. So any sudden process is instantaneously approximately adiabatic. Remember this. As if you are doing in an insulated vessel, but actually you are doing your process in a closed system with a diathermic wall, with a conducting wall, but suddenly you are doing. These sudden processes are called irreversible processes in the language of physical thermodynamics. But in chemical thermodynamics, not chemical exactly, while dealing with chemical reactions, reversibility and irreversibility have completely different meaning. So we have discussed types of systems and boundaries. Adiabatic boundary to carry out a adiabatic process in an insulated system. Closed system, we will carry out all the non-adiabatic processes as well as open system. So then we talk about, this is important, extensive property. Thermodynamic property like volume, this volume, and we'll be discussing internal energy U, enthalpy, heat capacity, not specific, heat capacity. So I am telling, say Cp prime means heat capacity. I'm not adding the term molar or specific. Of the whole entire bulk of the matter, whatever you have. So entropy, we'll be discussing that. Volume, these are size dependent or mass dependent, quantity dependent. More is the quantity, more is the enthalpy or internal energy or volume or entropy, or later on Gibbs free energy. So these are extensive properties. But there are intensive properties which are size independent or quantity independent, like temperature, like pressure, like molar heat capacity or specific heat capacity. Therefore I have put a prime here, molar. In chemistry, we are familiar with molar, but in physics there will be specific per kg, but in chemistry it is per mole. We can do everything. Molar heat capacity. Even specific internal energy, specific volume, per unit mass or per mole, volume per unit mole or unit mass. This is specific internal energy. I think you might not have had this. There is anything specific, mass independent. This is specific volume. Viscosity, refractive index. These are not dependent on quantity of the substance. They are quantity independent. Even pressure. If you have a gas fixed, in a container, whether you measure the pressure at this area, force per unit area, or the entire force per unit area, pressure will be throughout same. It independent whether you are measuring the whole cylinder or a part of the cylinder. If the system is fixed, then its pressure is fixed, independent of the quantity. This. Now, at this time, let me tell you, to define a system uniquely, we need only two independent intensive variables. Independent, not dependent. We'll not discuss about that now. If you want to include extensive, then you have to say unit for fixed mass. Therefore, it is better of two variables, intensive as well as extensive, for fixed mass. Fixed quantity, fixed mass. So if we fix two independent intensive variables, then all other variables are automatically fixed. You can define a system, whether a chemical system or a physical system, uniquely. Its entropy, internal energy, Gibbs free energy, everything will be same if two of the independent intensive variables are fixed. Now, there is another term called state function. This is path independent. If you are going from, say, one point to another point and find the difference between the two, so that difference is independent of whether you go in a shortcut way or in a long cut way, in a twisted way, spent a long time gossiping with your friend, doesn't matter. Only initial state and final state. They are path independent, all excepting work and heat. U, internal energy, enthalpy, entropy, we should be discussing, free energy. These are path independent functions. But exception, all thermodynamics functions, all except heat. When I say heat, I mean that it is a mode of energy transfer. And work, this is another mode of energy transfer. Supposing Q, these are the two modes of energy transfer. When I say energy, I mean internal energy or thermal energy. Better let us call thermal energy. Modes of energy. Supposing I will brand heat as dollar. Supposing dollar, and work as rupee, Indian rupee, INR. These are the two currencies for energy transfer. Which energy? Thermal energy. Interestingly, heat transfer can happen with only a temperature gradient, difference in temperature. There is a restriction. From a higher temperature, it will flow to a lower temperature spontaneously. Second law, we'll talk about that. But the reverse is possible. That is also second law, but not spontaneously. Under coercion, work has to be done. Then only even heat can go from a cold body to hot body. That is the principle of refrigeration, principle of air conditioning, heat pump. We'll talk about that in second law later. So only the difference is difference between heat transfer and work transfer is heat transfer occurs when there is a difference in temperature. Higher temperature, lower temperature, then only heat will be transferred from higher to lower. And remember, this will bring about disorderly motion of both system and surrounding. When heat is transferred, the molecules will be more chaotic, and their random motion will be more. The disorder will be more. But work is other gradients, like mechanical potential gradient. Water automatically flows from a higher level to lower level. This is mechanical potential energy. Electric potential, higher potential to lower potential, the electricity flows. What physics people call the current is from higher potential, positive potential to lower positive potential. So that is called electric potential. Similarly, we have chemical potential where a redox reaction will happen. From a higher oxidation potential, electron will go to a lower oxidation potential, or from a lower reduction potential to a higher reduction potential. So other gradients like chemical potential gradient, electrical potential gradient, mechanical potential gradient, then even pressure gradient, a high pressure and suddenly that was exposed to low pressure, there will be expansion. It was under high pressure, low pressure, then suddenly it was exposed to high pressure, it will be compression. So pressure gradient, these will be involved in doing work. So only temperature difference, temperature gradient will bring about heat flow. That is one mode of energy transfer. And any other difference in properties like mechanical potential, electrical potential, chemical potential, pressure, all these will bring about work. And work, what's the difference, It is the orderly motion in the surrounding. Most important, Ruchi, this one. This will bring about disorderly motion of both the surrounding when you are applying high temperature to a system at low temperature. Then high temperature substance will now try to push the molecules in the vicinity. So they will be disorder. They will be hitting the wall. The wall molecules will be hitting. Then it will be hitting the first molecules of the gas. They will be hitting. So all are disordered. But in mechanical energy transfer, you supposing compress by your hand, you are the surrounding. So there is an orderly motion of the hand, then only you can transfer. Inside the system, thermal energy is increasing. So there will be disorder. But in the surrounding, the work transfer will be involved in a orderly motion of the molecules and everything in this surrounding. That is the major difference. Another difference. One difference is gradients are not temperature gradient, other gradients. The other unique difference is creates disorder in both system and surrounding. Which one? Heat flow. But work flow involves orderly arrangement of the surrounding. Remember this, I'll ask you. So Q and W about which we are talking, they are path dependent. They are not state functions. Are not state functions like others, volumes, all others excepting these two. But there is a caveat. Under some restricted condition, we'll see an isochoric process Q will be a state function. That is the only restriction. Stipulated condition. Suppose in an adiabatic process, work will be a state function. It is path dependent. Independent. But all other cases you will find you go in this direction, the work done will be more. Go in this direction, the work done will be less. So it is path dependent. But under very restricted conditions, W and Q can be path independent or state functions. So guys, understood. So Ritu Parna writes, yes, understood, sir. If when you find any difficulty, because I'll be doing justice to all varieties of guys who are beginners, who are revisioners, who are revisioners for the second time, everyone will benefit. I can guarantee you that. Well, when I correlate between the physical process, physical systems, physical process, and chemical systems, chemical process, you will find the charm and beauty of its application. Now coming to first law. Before coming to first law, let us now what is U? Internal energy. If we call it thermal energy, that will be also okay. U. Earlier in chemistry, we were writing E, but now physicists, chemists, they are writing U. So, U is the sum total of all mechanical potential and kinetic energy. Inside the system, there are molecules. The molecules, they have rotational motion, they have vibratory motion, they have rotational motion, they have translational motion. I'm sorry, for the first one I should have told translational motion, vibration, vibratory motion, and rotational motion. Both have their kinetic part and potential part. Particularly vibration has both kinetic part and potential part. So all forms of energy together, that will give you U, the internal energy. That is in fact the energy necessary to create a system. In fact, internal energy ho ya enthalpy ho, the absolute values you cannot determine. There are changes from state 1 to state 2, initial state to final state. There are changes, del U, del H, they can be determined experimentally. But let us define what is internal energy. What's the harm? Is the sum, but except energy called PV energy. I'll tell you what is. U does not include PV. For gaseous system, it is applicable. For non-gaseous system, well, all are in liquid state or solid state, so there is no PV energy. So internal energy does not carry. But if there is a gas, it carries a volume. So gas volume also requires some energy to create a space in the vacuum or in the air to displace other ingredients of air and dakhal par aa jao and take the propriety or remain in that position. That also needs some energy. So that is called PV energy, pressure of the gas and volume of the gas. The PV energy is not included in U, even if it is a gaseous system. U, all forms of mechanical energy, kinetic and potential together. So in fact, U is a measure of temperature. Of course, for fixed mass, I should have written specific internal energy. Here, we miss out. Supposing temperature, we have a large mass and a small mass. The large mass having the same temperature will have large internal energy. But a small mass at a higher temperature will have the same internal energy. So how can you say U is proportional to T? Unless you fix the mass or the number of moles. So U is proportional to T. It is all measured by thermometer. How much of thermal energy is contained in a closed system or an open system? Open, nobody bothers. Or an isolated system will be determined from thermometer. Temperature, if U will change, temperature will change. Remember this. If U changes, temperature changes. Then, we will straight go to first law. In an ordinary sense, we say it is the energy can neither be created nor destroyed. This is middle school level first law. But for you, in an isolated system, you are carrying out an isolated system, or if you are carrying out an open system, most of the reactions are not open but closed systems with a dithermic wall. We say the universe. Oh, I forgot to tell you that system and surrounding, we have a term called universe. Don't be so much biased or swayed away by the term universe. Don't think of stars and the sky, heaven. Don't think of that. System where you are doing some work, maybe the internal combustion engine, maybe the battery, maybe a chemical reaction vessel, closed vessel, whatever. That is the system we are studying. And the rest part, mostly the immediate vicinity, the surrounding, that is surrounding. And surrounding plus system together is called universe. Some people call total, some people call universe. So first law says that in an isolated system, just write down, I will give you beautiful notes. System or universe. Universe contains system and surrounding. Heat can exchange, matter cannot exchange. Isolated system, everything will be there. Whatever heat created, whatever work will be done, will be done on it. What can be done? Heat cannot be done or given. Heat cannot come out, but work can be done. Work can be done by the system. On the system, everything can happen. Work is omnipresent even in isolated system. It is there. But heat, no escape, no entry, no escape in isolated. In isolated system or universe, the total currency that I earn in dollar and India I go and earn in rupee must be equal to U. Tell you. Change in internal energy. This is change in internal energy. So this is just like bank balance. Supposing you have an account in Swiss bank. So while you are in US, you are earning in dollar. So you are giving the bank. Swiss bank has outlets everywhere. Everywhere it has got openings. So you are simply taking your dollar and depositing in your account. And you are staying 6 months in India. You are earning in Indian rupee. And you are also keeping in the Swiss bank. There also in India there are Swiss banks. So you are depositing money in both dollar form and in heat form and in work form. But it is consequently it is increasing the internal energy. Similarly, supposing you have some urgency to work, you are building a house, you will draw money. So you draw some dollar, so your bank balance will fall down, your internal energy will come down. If the system will lose heat, it is an exothermic process, system will lose heat, so its energy will fall, thermal energy, internal energy will fall. If it will absorb, it is taking heat, it is taking dollar, then its bank balance, internal energy is bank balance will increase. So if it is, the work is, here lies the difference between physics and chemistry. In my sentence, maybe you might love chemistry for some time. When we do work, supposing piston, you are holding the piston in your hand and compressing a cylinder, there is a gas. You are doing work on the system. So work is done on the system means the energy is transferred into the Swiss bank. So internal energy will increase. So that is, we say, positive work. The acquisitive convention, I will take you the difference. Where in physics questions, you will be doing what? Only difference in the sign convention of work. And that is why work is taken positive when work is done on the system. Just think, imagine that you are holding the piston and yourself with your muscle, you are pressing down, you are doing work. Automatically increase, internal energy will increase. It is transferring energy. Work is a mode of transfer, or it is ultimately increasing the internal energy. U is increasing. So increasing the balance. So ये तो बनता है, पॉजिटिव देना बनता है, तो chemistry people take pride. So you are increasing something, you are telling it minus. So no, and when the system expands, supposing some gases are formed, supposing it is under high pressure, immediately it comes to a low pressure. So it expands. So then the system does work against the surrounding. So it spends its own reserve, thermal energy from its own reserve of internal energy, it spends performing work against the surrounding. In that case, we say the bank balance decreases and we say the convention of work is negative. Now, let me give you the sign convention. Both of them change, whether increases, del U is positive means increase U, excuse me. Sorry. Yes. And a del U negative means decrease in U. Now, sign conventions of heat. This is same for physics and chemistry. Heat absorbed will increase the bank balance. That means you are putting more dollars into the bank balance. Heat evolved. That means you are losing dollars. So the internal energy will fall. So it is negative. And work in chemistry, that is called acquisitive convention. Work done on the system. By whom? By us. Us means surrounding. E is positive. Work done by the system is negative. This is the only difference that we find in physics. On the system is negative, by the system is positive. We will not be using here. Whenever you use in your physics classes, so you can find the difference. Same, but answer will be same. Because the expression for work also has an opposite sign. So opposite, same. So supposing I will give you a question. Supposing a system evolves 300 joules of energy, heat energy. When I say heat energy, that means transfer has happened through heat. And hundred joules of work was done upon it. What is the change in internal energy? Do it. Change in capital U. What is the change in its thermal energy? Do it. But a process hela through heat release. The heat release was 300 joules. All our energy. So we can either express in joule or calories, doesn't matter. Siddharth, a guy, a very intelligent guy, is asking me why the sign convention an opposite in physics. I will ask a counter question which you cannot answer. Some other time I will answer. Does proton from the nucleus move? No, proton and nucleus, they are static. But still we say the direction of current. Actually, instead of saying the direction of the movement of protons nakohiki, we say the opposite to the direction of electron flow. Actually, electron moves. Maybe drift velocity is very low, but the energy transfer is very fast. Whatever, it drifts. Protons, but still we take the direction of current is from positive to negative. That means, so this is a convention that has been adopted long time immemorial. So the convention in physics and chemistry, they are opposite in work only, but the conclusion will be same. That is why I told you that while I say when work is done on, you feel like you are putting something. Actually, it is increasing internal energy. So why should we say minus? Why should we not say plus? You will be more convincing to the acquisitive chemical convention than the physics convention. So don't fall into that trap. Physics people will convention is convention. There must be some reason behind it, but let us. Controversy, Jivani. So, answer the Ritupurna says minus 200. It is okay? Are you there, Prabhu? Yes. Now see, I am answering. The energy has to be conserved. The sum total of heat transferred and work transfer will be equal to the bank balance. That net change in the bank balance. So the Q was joules evolved. Evolved means negative. Heat evolved, sign is negative, always loss. And work is done on. Upon means on. That is positive. You have to apply our convention. So plus 100. So the result is minus 200. So there has been a decrease in internal energy, not by 300. Had there been no work done, then the decrease in internal energy would have been exactly equal to the heat lost. But at the same time, work has been done. So work has been done means that 100 joule was involved in increasing the internal energy, but 300 joules were involved in decreasing internal energy. So net decrease in internal energy is 200, so minus 200. That is sign, you have to be very particular. Okay. You know, in our body, roughly we can say the first law and second law, both the laws are governing. If you only take food and do nothing, do you think the first law will be kind on you? No. You have to spend the energy, chemical energy you are taking, but that is converted. The cellular respiration is also the respiration, and the cells that also is demanding some energy you are spending. But the food that you are taking is not very small. It's much more than what your cellular respiration and other vital organ are needing. Even if you don't do anything, always eat, sleep, do nothing, even some energy will be spent out. But the rest energy, if you don't spend it by doing exercise, mechanical work, you spend the energy in the form of doing work on the surrounding. If you don't do, then the rest of the energy will be definitely stored as fat. So we blame on somebody else, but if you become obese or fatty, then it is primarily we. We dishonor first law. We take and don't spend. So that is why we become fatty. And most of us, particularly when we are grown-ups, above 30, we start looking at the area below the chest. You'll find a bulging out like this. That is almost universal. Almost, I say almost. Why? Same reason we are not carrying first law. Second law also will be holding good. When we come to second law, I'll tell you. Now we shall be talking about most important thing, irreversible and reversible process. You all jot down in your copy, but my handwriting, I am not able to spend time to make my handwriting look good. Oh, by the way, I am not as bad handwriting as you see here. Not as good as what you have, but it's good. Oh, I am extolling myself. Now you will also say, let me give you a test. Is the streaming going on fine? Is the Facebook? This is my first experience in. I was usually going live in YouTube in all my previous, but first time I wanted to make a test, and particularly with OBS, this is my first. Of course, a periodic table day celebration for the class 10 was my first, but it is the second one. But that means it is in its infancy. My experience in OBS connected to FB, Facebook, is in its infancy. Baby. Why I decided not to use PowerPoint slides, because that will not help the beginners. Maybe some revisioners who are really good, they will be enjoying. physical process, like I will take two observations: expansion, compression, that is involved in a heat engine, may it be internal combustion engine, steam engine, whatever. It is called heat engines, which runs on combustion of something, production of gas, compressing it to high pressure, then expansion, giving stroke. Of course, our 4-stroke car engine is not an idealized reversible Carnot cycle engine, but thermodynamics principles are applied. May not be ideal, but we look for what is the efficiency. We'll talk about that in second law. In physical process, I don't write physics. Physical process doesn't mean that a phase transformation, phase transition, ice melting, liquid water vaporizing. Those are physical processes, but I'm not talking about that. They will be treated in a different way. So I'm talking of expansion and compression. All irreversible processes are called natural processes. And they are done very fast. Equilibrium attained once. Initial state, then final state. No other states you can visualize because it will go so fast. Go fast. Fast expansion, fast compression. So, and most importantly, later on we know that the entropy of the universe, universe mane tum bhabani, I am talking of the tara. Universe mane bujla, system and surrounding the entropy change. What is entropy? Forget about it. Will be greater than zero. There will be some entropy is produced. We say entropy is produced. That means you cannot, dekho, how different it is. You can go back. Supposing you are expanding. This is forward process. Same substance you can compress. You can go the reverse direction. So still it is called reversible. Why? What is the fallacy? This is illogical to me. I'm sorry. I'm not. I am great fan of physicists who really propounded the principles of physics. But this confusion has to be clarified. Once clarified to the students, physical process, chemical process, process in equilibrium, already phase transition, they are separate processes. So the entropy is produced means you cannot come back to the same state. You can revert. You can reverse. In the name of irreversibility, you can reverse. But you cannot come to the same state of the universe. You will be definitely either increasing the entropy of system or surrounding compared to the decrease in the other, so that the net change of the entropy will be positive. There will be entropy will be produced. But we shall see in a reversible process. So slow, let me tell you. So it is all work is heat is dissipated. So friction is the main villain. Why? We cannot achieve the original state without reducing entropy somewhere, either in the system or because friction plays a villainous role in taking away the energy. Now, for that, supposing you are carrying out a expansion process. Here, there was a 20 kg weight. It was there. And a gaseous system is there. Suddenly what you do, you remove this and put a 1 kg weight. What will happen? It was under 20 kg pressure. I am not calculating the pressure. 20 kg pressure. And suddenly you removed it. In a moment you replaced a 1 kg weight. It will expand against 1 kg. So, it happens when there is large pressure gradient. 20 kg, 1 kg. The more the gradient, more the difference, more is the irreversibility. Irreversibility, you think of speed, fast. When there is large pressure gradient or pressure difference, then irreversibility sets in. Only one equilibrium, initial, then final. No in between. So the work is done against the external pressure. Not kete thila. It was under 20 kg pressure. No. There is no more. It is gone. It is a history now. Now whatever moments it will need for expansion, it is now reacting to 1 kg weight, not 20 kg weight. So it will be relieved very, very comfortably, very easily. And you will see the work done will be so less. Work done against external, PEXT, external. Similarly, supposing you have a 1 kg weight, then you remove it and immediately put a 20 kg weight. It will compress. It will undergo compression. A lot of energy lot of work it has to do against the friction, because you are not allowing it to equilibrate at different times. Stay and breathe. You are not giving it any breathing time. So here the external pressure is 20 kg. Yes, 20 kg is not a pressure. Is equivalent to. And here the expansion, the external pressure is equivalent to 1 kg. It is expanding under 1 kg. Here it is compressing. This is compression. Oh, I was wanting to give a test on my quality of handwriting. Now I will give. So the external pressure is equivalent to 20 kg. Therefore, when we find the work done, now let me tell you, the irreversible work done or anything is minus. Why minus? I will tell you later. P external, this is very important, into change in volume. That is P external, V final minus V initial. So you can get it very simply, because if you take a small work, delta W cannot be D. Work is an inexact differential. Work and heat. You cannot give a sign D, delta, small delta. dW is equal to minus force into displacement, supposing ds. Force is equal to pressure into area. Area into displacement, whatever little displacement it will go up or go down, that area of cross section gives you volume. So it is equal to minus P is dV. Here volume is a state function. It is an exact differential, but W and Q are inexact differential. You cannot have an expression of as we shall discuss later, how an exact differential can be expressed as a function of two variables. As I was telling, only two variables, independent variables, have to be fixed in order to uniquely define a thermodynamic system. A thermodynamic equilibrium means the attainment of thermal equilibrium, no heat transfer; mechanical equilibrium, no motion or no work done by or on; and chemical equilibrium, no more apparent chemical reaction happening. All the three equilibria together is called thermodynamic equilibrium. See how it is taking its fold: mechanics, thermodynamics, thermal heat, chemical equilibrium. Together it is thermodynamic equilibrium. So do you mean chemists have only 1/3 of share of thermodynamics? We will have 100% share. Kidding. You'll see. See, I'll be disseminating my experience as well as training you for the IIT JEE Advanced. You'll be able to solve problems. What to speak of NEET? Of course, NEET problems, NEET questions are very intelligent questions. Once you understand, you can answer all the questions. But tougher questions are in IIT Advanced. So we are eyeing on that. But when you are eyeing on the Everest to summit in Kilimanjaro, is a trivial job. Is a bayat ka khel. Oh, this is self-aggrandizement. It's not good. Okay. If we replace, Jivan Jyoti is asking, if we replace 20 kg by to 19.5 kg, then it will be slowed down. And it will be inching towards reversibility. It's not. Still it is irreversible. Work done. I shall show you if you are having a small little knowledge of integration. Area bound by the curve. You will know that a graph of a curve, the area bound by a curve, that is an integration, and suddenly going from a high pressure to low pressure, volume changing suddenly large, so that area is very small. And as you narrow down the area bound by the small curve, and this tall rectangle will be nearly same. So it will be inching more towards reversibility, but still the reversible expansion work is more than the irreversible. Yes, your question is definitely irreversible, but it is closer to reversibility. Am I clear now, Jivan Jyoti? If you are watching, you must also interact with me. That will give me a lot of encouragement to speak out. Sir, आपन को face right side bottom corner रे show. Sir, आपन को face right side bottom corner रे show करूची. So सेठी जहाँ आपन instantly लेखुचंती. Oh, सेटा visible होनी. Oh, right. मु आउ सेठी लेखिबिनी. Thank you, Ramesh. I mean, Prabhu. Thank you so much. Mu epot ku jibini. Mu dekhuni. Okay. Is it okay now? Or I shall scroll down, scroll up. Hey, Prabhu, will I scroll up so that you can you have understood? मु आउ ए एरिया रे मोटे आउ जीबिनी मुटे केमती लक्ष्मण रेखा कर देबी ए एरिया रे मु जीबिनी आउ hopefully till now this blunder of mine will not has not produced any a negative result on your understanding. कौन ये सर बुझी पारछ तो सिद्धार्थ मु जो एपट को पळे आसली राइट साइड कॉर्नर को तळ को लेखा लेखी कर देली से जो लेखिली हैव यू अंडरस्टूड और विल आई हैव टू स्क्रॉल अप ओके नाउ आई विल नॉट गो henceforth as we are inching to a more and more interesting aspects. ये तो पिक्चर अभी बाकी है, ये तो शुरू हुआ है, पिक्चर अभी बाकी है. We will be closing after half an hour. Maybe I will take little more because we have started 15 minutes late. So please bear with me, and we shall be testing the credibility of Facebook. Why I came to Facebook? Let me tell you, because many of you know that I was a YouTuber, but I was not using Facebook till recently. Maybe 3 to 4 months back, I was skipping Facebook. If Facebook is watching me, I'm conceding, I'm submitting that I was not using Facebook till 3 months before. I was having an account. It was only meant for giving notifications. Giving notifications. Only when I'll be doing, because the notification system is not there in YouTube. So I was taking the advantage of Facebook to notify to my friends. But Facebook is very intelligent. Whatever is not done on the Facebook will not be circulated. It will not be circulated. If your friends, it will be given to your friends, but it will not be circulated to public. But here, it will be circulated. So I thought, that let me see the stream. How is the efficiency of the streaming? I was using Zoom. Zoom, it is not a 4K video. Now you are getting 4K video, as I'm inclined to believe in OBS. So if the stream, maybe there is a lag, no doubt, whether it is Zoom or your other YouTube Zoom or OBS Zoom, OBS YouTube or OBS Facebook, there will be a lag. Whatever I am saying, you will be listening maybe few seconds, 1 or 2 seconds late. I don't know. I have to prove. Okay. What I was saying, I forgot. Yes. So when you integrate for the entire path, so this external, which is a constant, it will be outside the integration sign. So this will be total work done is equal to minus P delta V. That is V final, so V initial, V final, these are the limits. Initial is the lower limit and this is the final limit. And finally it will be minus P external, must write V2 minus delta V or Vf minus Vi, V2 minus V1. So why this has been minus? See, why chemists have put minus sign here in work? Because expansion going from a lower volume to higher volume, del V is obviously positive. So if this is positive, then work is negative. Our work convention, work done by the gas, it will be exhausted, it will be tired, losing its own energy, its own rupee, and its internal energy will decrease. So expansion has been kept as negative. So minus is there to make the work negative. For expansion and compression, delta V is negative because you are going from a higher volume to lower volume. So final minus initial, 2 liters minus 10 liter, it will be minus 8 liters. Therefore, when delta V is negative, and if there is a negative sign before that, minus minus plus, so work will be coming, positive. Your work negative, your work positive. That is why we have given a negative. But in physics, work done is plus P delta V, P external delta V. Only this much of difference, but the exact same thing you will get. Their sign convention in work done is opposite. Here, the expression of work done opposite. So opposite becomes, so when you calculate del U, it will be coming same. Cannot be different. Del U, change in internal energy, increasing or decreasing, cannot be opposite, can never ever be opposite, then science will go wrong. So, now I was telling you, supposing this is the initial volume and this is the final volume. It goes from a very high pressure to a low pressure. But low pressure, supposing 1 kg, I write in place of 1 kg, I write 1 atmosphere. In case of 20 kg, I write 20 atmosphere. So it has done work against 1 atmosphere, expansion. So the geometry, that is, this is delta V and this is P external. So nothing but the area bound by the small rectangle. Is the irreversible work minus P external by N2 delta V. You will see how reversible work is going to completely change the scenario, is reversible. Immediately we come to reversible process, which is non-ideal, is ideal, which never ever is possible. We have to set a standard, ideal standard before us, and we will be planning how much close we can go to the ideal value. So let us study that ideal value. Is proceeds infinitesimally slowly. Infinitesimally slowly. How do you pronounce? Infinitesimally slowly. infinitesimally slowly. And across the path, it encounters infinite number of equilibrium. This is called quasi-equilibrium. Some people call it quasi-static. Quasi-static. Infinite number of equilibria steps. So always P external is equal to P internal. At every moment, the inside pressure and outside pressure, they are same, because it is taking place infinitesimally slowly. And Boyle's law now comes into picture. If done at constant T, if done isothermally, I will talking about that later. If done in a constant temperature, then Boyle's law will come. The graph, you know, is an hypothetically ideal. So just like we removed P external outside the integration sign, here we can't do that. We have to keep inside. And no entropy is produced. When you reverse in the same track, you will have to go in the same track, curved track, and when you reach the initial state, from the final state, you will find the universe is, surrounding has the same values of entropy and every other thing, and the system also is same. So there is no change of entropy of the universe. That is the beauty of, because there is no friction, no villain. Ideally, there is always friction, there is always heat dissipation, but this is ideal. We have to learn that. And how to find the work, actual work. Now see, then I will tell you the graph. Work, same. Start dW, delta W is equal to minus P. Now we shall write internal into dV. Now when you integrate, the integration sign will come ahead because this is constantly changing. As supposing you just think that you have 20 kg of sand, not a weight, 20 kg sand is sitting on this piston, over the piston, and it is in this volume Vi. Now you remove sand by sand, 1 grain at a time. In this bath, you cannot remove all the grains of sand from 20 kg sand and bring back to 1 kg sand. So if you do so and bring back to 1 kg sand, this is a hypothetical reversible process, which is impossible. Remove 1 grain at a time, 1 grain at a time. Is it possible? So that the system will come to equilibrium at every moment. It will work, it will expand, it will do expansion work, negative work, but so infinitesimally slowly that when you go out for 1 hour to watch a movie and come back, they say nothing has happened. Oh, is it expanding? Then Prabhu will be sitting there, remembering Prabhu will be, Sir has told to remove 1 grain at a time, so we'll be removing 1 grain. So nothing will be visible, but when you come after 20 years, maybe some visibility will be there. Yes, is that expanded? So let us do it. For the sake of theory, we do. It is necessary also. I have not yet come back to chemical processes. I will come back sometime. I close this chapter. Close this reversibility. Then I'll come back. What is the meaning of reversibility and irreversibility in chemical reactions? Now coming to, this will be W, and this, in place of this, we write nRT by V, because PV is equal to nRT, you know the famous ideal gas equation. So from there we write P as nRT by V, then dV. So since supposing we were dealing isothermal process, immediately I make a caveat here, isothermal system, so that temperature remains constant is equal to minus number of moles mass constant, R is universal gas constant. So bring nRT outside, then it will be dV by V. And of course, this will be from V1 to V2, V initial to V final. So when we, again I am, sorry, I will not go. W is equal to, when you go from V initial to V final, then can anyone remind me what is integration 1 by V dV or 1 by X dx? This is mathematics, a bit of mathematics. It is ln V. So V1 and V2. So that finally the net work done in a reversible process is nRT ln V2 by V1. So since temperature is constant, we have stipulated to be an isothermal process, we can use the Boyle's law, minus nRT ln P1 by P2, because pressure and volume, they are inversely related. And this is reversible. You must write reversible. And for your examination purpose, you have to convert ln into log, so that you have to multiply 2.303 nRT log to the base 10 V2 by V1, or it is minus 2.303 nRT log P1 by P2. So this is the graphic. Again, okay. Sorry. Again, if I to show from the V initial of 20 atmosphere to final 1 atmosphere with the initial volume is Vi, final volume is here supposing Vf, then it will, since it is integration, it will be a curve. So the whole area bound by the graph, by the curve, this is the expansion curve, reversible expansion curve, Vi to V. So the curve area is the maximum. But if you compare the same volume difference and same pressure difference done fast, इंडियंस क्यों इतने जल्दी में होते हैं? In Europe, Australia, US and other developed nations, because I'm not comparing, because the population is so low, therefore the mindset has been so fixed that when they see a pedestrian, person walking on foot, they are called pedestrians, as you know, they shy away. Immediately they stop. Same जाते हैं वो drivers. They say go. Even if they are not in the pedestrian path somewhere, of course that doesn't mean that accidents are not happening. If somebody is going when in the main road where the pedestrian light is red, he is crossing, and cars, they come with a very high speed. They are going, they have no chance to brake. It will straight go on you. But I am saying in other places where it is going. But we will never allow anybody to go unless we go first. Some persons are waiting to pass, cross the road somewhere. We don't bother. Let him, they are secondary, tertiary. Pedestrians are tertiary. The riders, the car riders, the followed by scooter riders, they are primary. So the mindset is different. I don't compare. You have to decide. So this small area is the irreversible expansion. And this area is the, this area is the is the reversible expansion, because it is log P1 V2 by V1, so it will come, we have integrated the entire, taking dV and P integrated from the initial limit Vi to the final limit Vf, and we got the area bound by the entire curve, not area bound by the rectangle. But now see the difference. Let us look to the compression, where almost 99% of the books that you have, you check it today, there will be no mention about what will be. So definitely the expansion, the work reversible is much greater than the work irreversible. It is done under constant small external pressure, the area of the small rectangle. When he was telling from 20 kg to 19.1 kg, so this rectangle will be very close to the area bound by the curve under this portion. So it is inching towards reversibility. But here there is a large difference between the curve bound by the curve and the area bound by the curve and the area bound by the small rectangle. So more is the pressure gradient, more is the volume difference, and hence the area will be smaller and smaller if done irreversibly in a fast process expansion. But coming to compression, situation is same for reversible. Reversible compression will follow the same track. So this is your VI. Now this is your V final. I'm talking about compression. You go in the same direction. The path in which it came through expansion from VI to VF, it will go trace the same path. It will not produce any entropy elsewhere. That is why it is producing, it is going in the same track but in the reverse direction, repeating the same equilibria steps in finite number of equilibria steps and reaching the final volume. Here delta V is negative, but it is compressed under 20 atmosphere pressure. So the area bound by this graph, this large rectangle, is much greater. This is W irreversible compression, but the area bound by the graph is same. Whether it is expansion or compression, it is minus nRT ln V2 by V1, same. This will be, in expansion it will be coming negative work, and in compression it will coming positive work. V1 by V2, V final is less and V initial is more. So this ln term will be negative and negative will be positive. We'll be doing a lot of numericals. It will be very easy. We'll be also taking up some interesting problems from NEET and JEE advanced also and main also. So here compression, irreversible work is greater than reversible work. Just tell me how many books will tell about, they will always tell one sentence, reversible work is more than irreversible. Baba, in a engine, whether it is Carnot cycle or ideal engine or non-ideal engine, there is compression, there is expansion. In compression, the work done is more than the ideal value. In expansion, the work done is less. In irreversible fast process is less, much less. So remember this with caution, that in compression, irreversible work is more because it is the big rectangle area, which is far more than the area bound by the curve than the reversible. And in expansion, reversible is the hero. We compare always with the expansion to what extent we can go close. Got it? PowerPoints I will share with you. I will show you and you will be really surprised, surprisingly happy that I am sharing so many PowerPoints. Let me tell you a secret. If somebody, parents are watching me or some teachers will be watching me, I have invited all teachers from different schools teaching 11 and 12. So for them, all teachers know that for a teacher, the learning is every day. What you are learning as a student, we are learning more than that. So my PowerPoint videos are being upgraded for the last 45 years, for more than 40 years. Every year I am upgrading it, adding to my own experience, learning more and disseminating more. So when I'll think that I'm not able to learn more, then I will stop teaching. Stop creating videos or lecture series. I will stop. Promise. and you are allowed to ask me a question which perhaps will give me an impetus to learn more. I will say, sorry, I don't know this. I will try to learn and tell you. I will go after you, no doubt. Now, let us talk about now supposing you are one step, you have gone from 20 to 1 atmosphere. So the work done is very less. You will be applying the formula minus P external 1 atmosphere into delta V. Get it? 1 liter atmosphere, as you know, is nearly 101.3 joule, or 1 liter bar is exactly 100 joules. So you can also use this liter atmosphere and convert it to joules with the conversion values. Now supposing instead of doing in one step, you do in 2 steps. First 20 kg to 5 kg. So, and the volume will definitely not this one. Supposing the final volume was 10 liter, it is 1 liter. So it will be somewhere here. So first you have to find out the rectangle, this rectangle area, and then you have to find out, you are going from 5 atmosphere to 1 atmosphere, then this area. So you have to add this area with this area. So definitely it will be more than this area. So more the number of steps, supposing you first come down to 19, then to 18. So this, then this, then this, then this. So no more number of rectangles will be added up. So it will be the total area of the rectangles will be inching very close to the area bound by the curve. So more is the number of steps, more close that the process is towards reversibility. More is the number of steps, more close we approach towards reversibility. Oh, I'll show my handwriting. So we'll be solving problems, not today, but tomorrow first we will be completing the theory portion. Then comes the important thing is enthalpy. So only if you remember H is equal to U plus PV, del H is equal to del U plus P del V, it carries absolutely no meaning. Oh yes, you have become a doctor, okay. But when you teach to your own children, or if you by chance become a teacher, then you have to study very hard to understand things. Teachers, in their student stage, they might be average student or maybe poor student even. But in their teachership career, they have excelled to be a brilliant teacher. Why? Because at that time they were not studying. This time they have become real learners. Every day they are learning and improving their skills and their knowledge stock. So they have proved themselves to be brilliant teachers. So enthalpy is let me introduce it. In closed system, when closed system I mean diathermic wall and boundary, diathermic boundary, and at constant pressure, not sealed. ढक्कन बंद नहीं है, खुला भी नहीं है, लेकिन movable piston है, so it will always remain at constant pressure, say 1 atmospheric pressure. It was found that there is always a return gift system. Gift exchange between system and surrounding in form of, I'm so sorry, in the form of W and Q. This is not for definition. It is for understanding. In Scientists found that whenever they are carrying out any process under constant pressure condition, they found there is always a return gift between system and surrounding. Supposing you add 100 joules of heat to the system, that means it is an endothermic process. So due to temperature difference, the system is absorbing 100 joules, okay, by heat transfer. Then all the 100 joules it cannot keep. The problem I gave you was based on this. It has to give some return gift to the surrounding. Often this is analogous to supposing your guest brings some sweet from some sweet stall packet. He gives a little big, but you give a 1, 2 or maximum to 3, 4. Can a person take 100 rasgullas or say 20 rasgullas that he has brought? But you give not from his packet. Nowadays we are giving. For me, who doesn't take sweets? Anybody brings sweets to my home, then I offer the same sweet. So usually we give different sweet, small quantity. So 100 joules, the system, supposing I am the system, I have received from you, you are the surrounding. I cannot use 100 joules to increase my thermal energy, internal energy. Some a part of it I will definitely give it back to you, Tamuku. I will give you in a gift packet, and that is work. Not same heat. The form in which I received, I will not give it back in the same form. The energy mode transfer will be now work. Work will be done by the system to the surrounding. And if I as a system will release heat in an exothermic process, Q is minus. In that case, surrounding also will have to give a return gift. Surrounding will do some work on the system. This is the basis of the definition of first law in physics. Oh, I'm sorry. I did not tell you the way physicists explain the first law. Now it is the time. They always say Q. Thermal energy, they start from thermal energy. Thermal energy. I'm so sorry. Heat exchange. Q is equal to a sum of internal energy and W. Don't be confused. They start from Q. We start from bank balance W, because that W has a different sign to show you it's positive, or whatever ln whatever comes. So if heat is positive, Q is positive, the system is absorbing some heat. It cannot increase its internal energy by the whole Q amount. A part of it will be used in expansion work. So in expansion work, they are positive. So out of 100 joule that you have given, so 100 joule is positive. You given, I am taking plus. So maybe 50 joule I shall return you back. And in physics, it is plus 50. In chemistry, it is minus, because we have minus sign here. They have plus sign here. So let me apply my convention to this thing. Del U is equal to Q plus W. This is our chemistry. So I have given the system. System has taken 100 joules plus 100. And it has to give a return gift. Expansion work it has to do under constant pressure condition. So minus 50. Expansion is done by the system, and that is negative. So ultimately, the net increase in internal energy by the amount 50, not 100, because I have given return gift. I am in a system. Similarly, here also, taking the thermodynamics law as Q is equal to del U plus W. So the Q is 100. So W is equal to plus P del V. So Q is equal to 100. Del U you have to find out, and W, since expansion work is positive, is 50. Then del U is equal to 100 minus 50, same. So there is, the answer of del U is coming same. But the law is different. Sign of W is opposite, and the work expression also, the sign is opposite. So when we in physics define first law, we say the heat absorbed by a system is equal to the net increase in internal energy plus the work done by the system. And simultaneously we say when heat is when heat is evolved by the system, that is equal to the heat evolved by the system is equal to decrease in internal energy plus the work done on the system. So two definitions you have to give simultaneously, and the expression is different, and therefore when we correlate between del H and del U, it will be different. Sign, the middle sign will be different. Hold on, we'll be continuing this acquisitive convention in our chemical, but you will never falter whether you are in a physics class or in a chemistry class, because we love physics equally well. We are not enemies. We salute them, we honor them. For them, we have got the huge application in chemical science. So therefore, we also study physics, particularly in thermodynamics. Okay. Yes. Oh, we will be closing. Now, since enthalpy, write down enthalpy change, which is del H, is heat absorbed or evolved at constant pressure. This constant pressure, whatever heat is taking, 100, that is under constant pressure condition that you have to apply. Constant pressure is enthalpy change. I have written here, the enthalpy change is the heat absorbed or evolved at constant pressure. So we shall write del H is equal to QP. QP, P means constant pressure. So since Q will be back to our work, del U is equal to now QP plus let's W plus W, in place of W write minus P, which is constant. That is why P is outside. Del V. We are using the irreversible notation. Del V. Minus is the sign convention here. W is equal to minus P del V. Therefore, since QP is nothing but del H, so del U is equal to del H minus P del V. So we got a very good relationship between del H and del U. Oh, pony, galti se mistake. So del H, enthalpy change, is the sum of internal energy change, constant pressure into volume change. That is relationship. But in physics, it will be minus. Minus is okay because their work expression is opposite, their work sign is opposite, so, and their first law is opposite, so they will come differently. So you can find out that. So in chemistry, we say enthalpy change is the sum of the internal energy change. So therefore, if you talk of the absolute, H2 minus H1 is equal to U2 minus E1 plus V2 minus V1, and then separate them. So you will find H is equal to U plus PV. Absolute enthalpy, which cannot be determined. Absolute internal energy at any particular system, at a particular moment, cannot be determined, is equal to the absolute pressure at that and absolute volume. So that means enthalpy is the sum of, this is theoretical definition, you cannot find out, the internal energy plus PV energy. This PV energy is only comes into force for gaseous system. The product of pressure and volume, which is an energy term, that energy we say to whom that it is the energy used for the gas to create space in the atmosphere and to occupy. So that is called PV energy. So when U is added with PV energy, we were excluding PV while defining U. Now while defining enthalpy, we are including PV. Then it becomes enthalpy. Enthalpy change is nothing but conceptually, we shall be applying them in all processes, adiabatic, non-adiabatic, all processes, enthalpy change. You will see in which case enthalpy change is becoming zero. We will be listing out. But the concept of enthalpy arose from this. That is gift exchange between system and surrounding when compression and expansion was carried out at constant pressure. Interestingly, the same will be valid for work. Supposing, see, in a closed system with a dithermic wall, constant, forget about constant pressure, we'll be doing the opposite. We compress by applying more pressure, we compressed. So we gave work transferred to system, internal energy increase. So all the work done on the system, it cannot digest to increase the external energy. It will release in the other form. Some heat will be flown because temperature will be increased from the surrounding. Some part of heat will be exchanged to the surrounding. So if you are giving in the form of work, then the exchange gift will be in the form of heat. If you are giving in the form of give and take the way in form of Q, heat, then the exchange gift will be, or the return gift will be in terms of work. If the give and take will be, guest will be giving and taking in the form of work, then the return gift will be in the form of heat. So that is valid for the other way. What I was saying. So these absolute values cannot be determined. But del U can be determined by a bomb calorimeter, where a isochoric process, a constant volume process will be performed, where we will be knowing that in constant volume, when del V is equal to 0, del H is equal to del U at constant volume. If V is constant, then delta V is equal to 0, so del H is equal to del U. In that case, we don't call it del H, we call it del U, which is equal to QV. So internal energy change has a different definition. It is the heat absorbed or evolved at constant volume. QP is equal to del H. So del U is determined from a bomb calorimeter. Del H can be either first determining del U from bomb calorimeter and then adding P into del V, or in a differential scanning calorimeter, DSC. Or you can use a isobaric calorimeter. Constant pressure calorimeters are available, where the pressure will be kept constant and it will record what is the amount of automatically temperature difference into heat capacity into number of moles. That will give you the heat absorbed at constant pressure. So they are measured, but absolute values cannot. You cannot. Only theoretically explain that enthalpy is the sum of internal energy and PV energy. So we have to sum up now. Del H is equal to QP, del U is equal to QV. So when del V is equal to 0, that happens in a sealed container. ढक्कन बंद कर दिया आपने, then you are not, just like bomb calorimeter, closed. The pressure will build up, and if you build up more and more and more, it may lead to catastrophic explosion. That is why it is giving a signal, a bomb calorimeter. It's not a bomb. It can be a bomb. Sealed container. Or when all species are in liquid form, are in liquids and solids, no gas. So if there is no gas and you are carrying out a process involving liquids and solids, then the change in volume is minimal. We say del V is equal to 0. Or we'll be telling now, in chemical reactions, when del N, number of moles, is equal to 0 for gaseous species. I'll tell you just now. So in that case, you will find you are really measuring del U, which is same as del H. No, we don't dishonor the word del H by saying del U is equal to del H, because del H is at constant pressure. It is something higher. I mean, the meaning is something different. But when you are not allowing volume to change, then you are really talking of internal energy change, which is the heat absorbed or evolved at constant volume. So under these conditions, whatever heat will be absorbed or evolved, it is nothing but del U. Now, in chemical reactions, what is? Supposing you have a C6H6 liquid plus O2 gas, which is combusted to give you CO2 gas, plus H2O liquid, and you balance it. Molar balance has to be done. 6, and here 3, 6 2s are 12 plus 3 18, 3 15. So this is 15 by 2. Just check whether I'm correct or wrong. 6 6, then 3, 15 by 2. So we can multiply by 2. Forget about it. So this won't be taken. This only gaseous, this will be taken, not taken. Had there been any solid, will not be counted. Only the delta N is the change in the number of moles from right minus left. Product, final state, in reactant, initial state. 6 minus 15 by 2 is equal to minus 3 by 2. That is del N. So you have to use that. Now see, we have said del H is equal to del U plus P del V. So applying the ideal gas equation, since P is we are keeping constant, so PV is equal to nRT. So something will change, then some other thing will change in the right side. That thing, temperature is constant, isothermal. So del nRT. So if the left side something will change, right side some other thing has to change. Here temperature is constant, so number of moles will change. Now here the number of moles change is 3 by 2. So for this pressure volume work, we have to take the gaseous, because liquids and solids, they are considered not to change any volume. Del V is equal to 0 for them. Only change in volume happens for the production or disappearance of gaseous reactants and production of gaseous products. So this is, in place of P del B, you write del N RT. So in chemical problems, we'll be using this one. So for reactions like this, where H2G plus I2G giving you H2HI2, all are gaseous. So here del N is equal to 0. So if del N is equal to 0, then del H is equal to del H is equal to del U. Their volume is also not changing. If del N is equal to 0, del V also equal to 0, Avogadro's law. So in that case, del H is equal to del U, and we say it is nothing but QV. Volume is not changing. So why to Ram ka naam badnaam? Ram ka naam badnaam ho. Some Hindi movie song was like this. So why to make badnaam to enthalpy change, which is same as internal energy change, but why not tell it internal energy change? So I think my planning was to complete first law. We are left with heat capacities. In gases, you will find, compared to liquids and solids, which have got only one heat capacity. In physics, you learn specific heat capacity per kg. But in chemistry, molar heat capacity. Both specific heat capacity and molar heat capacities are intensive properties. They are not quantity dependent or mass dependent. So in gaseous phase, you have two types of heat capacities. Heat capacity at constant pressure, the amount of heat required to raise the temperature by 1 degree Celsius is more by 8.3 joules when the same 1 degree Celsius rise will be happened in constant volume. ढक्कन बंद है, ढक्कन को बंद करके 1 डिग्री सेल्सियस राइज करो, जितना हीट चाहिए इससे ज्यादा हीट आपको लगेगा, क्योंकि रिटर्न गिफ्ट जो है the amount of heat required to bring about same temperature rise, because a part of it will be returned back to the surrounding, will be more by the amount R. So let me first introduce heat capacities, which is a extensive property. We write Cv dash and Cp dash. We have two for gases of gases. In gases, Cv dash is the molar, not molar heat capacity at constant volume. So Cv dash is equal to N into Cv, where Cv is the molar heat capacity. which is intensive property per mole. N is the number of moles, obviously. So you know Cv is nothing but Q by delta T. Not T, delta T. So, of course, if you look to the graph, I will show you the graph later. So, Q is equal to Cv dash into delta T. So, it is N Cv delta T. So, this is QV. QV is nothing but del U. So, del U is equal to N Cv delta T. Delta T is always T. Oh, sorry. Delta T always T final minus T initial. So, since QV is nothing but change in internal energy, so I have a formula pai gale del U is equal to N Cv delta T. Heat in thermodynamics heat physics re. So this is nothing number of moles the molar heat capacity, therefore we are multiplying with number of moles and delta T, and it was QV which is equal to del U. QV is equal to del U. Similarly, we have another one, Cp dash, that is heat capacity at constant pressure, return gift. At that condition, same thing, Cp dash is equal to N Cp. Cp is the molar heat capacity at constant pressure. I forgot to write down, this is the molar heat capacity at constant volume. Here, again, galti se mistake. That is Cv, molar heat capacity at constant volume. This is Cp, molar heat capacity at constant pressure. But Cp prime, dash, that is the heat capacity of the entire 1 kg, 10 kg, 20 kg, 20 moles, whatever. And similarly, since Cp is equal to Qp by delta T, Qp is nothing but equal to del H by delta T. So we find del H is equal to Cp prime into delta T, or N Cp into delta T. So now we got two relationship, one to find out del U under all processes, remember, whether it is non-adiabatic, adiabatic. Of course, in non-adiabatic isothermal, del U is 0. We'll tell about that later. But del U is equal to N Cv delta T. Cv is the molar heat capacity of that at constant volume. N is the number of moles. And enthalpy change into N Cp delta T. This is the molar heat capacity at constant pressure. And Cp minus Cv is equal to R. I was telling you, if you carry out 1 degree Celsius rise at constant pressure, you have to invest 8.3, that is R quantity of extra heat you have to give, because it will give out return gift in the form of work. And the Cp by Cv ratio is called the Poisson's ratio, not Poisson. S is not bis. Poisson's ratio. This is called gamma. Gamma, Cp by Cv. And for monoatomic gas, this is at a lower temperature. Okay, I'm not talking of higher temperature where vibrational degrees of freedom will set in. What is degrees of freedom? What is equipartition law? Equipartition law to find out the number of degrees of freedom, that I will not discuss now. But for general purpose, for monoatomic gas by like helium, argon, krypton, monoatomic gas, Cv is equal to 3 by 2. There are 3 degrees of translational freedom. No rotational, forget about vibrational. So monoatomic gas 3 by 2 RT, because the nRT. This is no R. I'm so sorry. Cv is equal to 3 by 2 R. U is equal to 3 by 2 nRT. So se through cardiala Cv part ta kehte na 3 by 2 R, and obviously Cp will be R more, will be 5 by 2 R. intrinsically it will need more energy. You add R to it. Then diatomic gas like oxygen, nitrogen, chlorine, etc. Cp, usually at lower temperature level, it is 5/2R. Eta C beta. I'm so sorry. And obviously Cp will be 1 or more, 7/2R. But here is a caveat. If you are carrying out high temperature, there will be more vibrational will come. It will be 7/2 and this will be 3. Or at low temperature, it will be 3/2. But usually we use at room temperature condition, it will be 5/2. 2 rotational degrees of freedom, and every degree of freedom will eat away half nRT. So as many number of degrees of freedom, the energy will be stored in all these degrees of freedom. So 7/2R, usually for your purpose. But little more knowledge is required. How and where it came from. So for polyatomic, like ozone, like sulfur vapors, like phosphorus vapors. So the polyatomic gas, it is CV is equal to 3R, because vibrational is not included. 3R because there will be 3 rotational degrees and 3 translational degrees. So total degrees of freedom is 6 into half nRT. So 3 nRT. So taking the only Cp portion, it will be 3R. Obviously Cp is equal to 4R. So, and the gamma, which is Cp by Cv, is equal to 1.67, highest for monoatomic, because tomorrow we shall be solving problems. And 1.4 for diatomic and 1.33 for polyatomic. So there are 2 CVs. The differences are, I think yes, we close here. Numericals will start numericals, and then we shall apply them to isothermal, adiabatic, isochoric, isobaric, cyclic process, and expansion in vacuum, and compare with the real happenings, free expansion. And of course, where there is no change of internal energy, will also include the Joule-Thomson effect, leading to the Linde's refrigerator used for liquefaction of gases. So we close today's session. How did you like it? Anybody still alive? Live in this program? Please give me a encouraging last chart. Yes, I am here. So that I will be happily close end the video. It is 2 hours, 7 minutes from now. Anybody still watching? Yes. Miss Ritu? Siddharth? Anybody? Anybody watching now? Let me, okay. Let me show you. I will be sharing yes, the first law, not yet finished. So I will be giving you beautiful, I'm scrolling it down. So which we have already discussed. Had I used this, I would not have been as natural. I did to my satisfaction. Your satisfaction is under your control. So these I will give you a problem and their solutions also. We have gone up to this level. Then we will be starting their application in different systems and solving problems. So this is the first law has not yet been covered. Yes, we have also discussed about these heat capacities and their values. All the proofs are there. Degrees of freedom also have kept. Equipartition theorem also have kept for you to understand why it is 3/2R, why it is 5/2R. Can it not change? So all these things were done. This will be doing in adiabatic process, reversible and irreversible process, and solving problems. The first half tomorrow, and then we will carry out introduce second law tomorrow. So anybody still live? Tankadhar Biswar, I could not note down. No, don't worry. I will give you the file in the same Facebook. I will give you the link where you can open from the drive, Google Drive. Automatically it will open, and you can download the file and study. Okay. Okay. If you did not scroll up, then you watch it again. It is not going anywhere from. Yes, Facebook, it is retaining, so you will watch it again. And Ritu Appa, are you still watching? Sibdat, yes, I am. And Sibdat also says it's a great session with you. Thank you. As usual, Sibdat, you used to encourage me, so you did. Oh, yeah. If you ask me, how did you enjoy your class today? I would say definitely a big yes, I did. बट अभी तो पिक्चर शुरू हुआ है, बाकी बहुत सारा बाकी है. सी यू टुमारो इन द सेम टाइम. आई थिंक देयर विल बी नो डिले. द फर्स्ट डे आई गॉट डिलेड. बाय बाय. गॉड ब्लेस यू.